this part. Let's look at our first special right triangle. Use your blank paper for this. We're going to do this one. This is called an isosceles right triangle. It's a right triangle because it has a right angle. Remember what's special about isosceles? Two of the sides are equal, or more, actually. But normally just two. This one and this one are our legs, and they're equal. And what I'm going to do is I'm going to make this side equal to 3. And that's going to tell me everything I need to know to find the other sides. We can find the other side because we know what it is. If you know what this side is, you know what that side is. That's what these little marks mean. What's this side? Well, 3, of course. And we also know the Pythagorean Theorem. A squared plus b squared equals c squared, where a and b are legs and c is the hypotenuse. Substitute your 3's in there and see what you get. Be sure to finish your problem all the way down. We're going to use it later, not yet. Three squared? Plus 9 is equal to c squared. Now instead of writing this as 18, I'm going to write it as 2 times 9, or 9 times 2. I'm going to write it like this. Instead of writing this 18, I'm going to say this is 9 times 2. And you'll see why in a second. Y'all see I'm going to take the square root of both sides to get c by itself? Remember that? You have to do the opposite to both sides. I want to get c, so I have to take the square root of this side, and I have to take the square root of this side. What is this square root when you reduce it? Everybody? 3 root 2, isn't it? Now, I did this on purpose. I want to show you a pattern. And this is the easy pattern. The other one's going to be a lot harder to see. But here it is. Do y'all see what would happen if I put an 8 right here and an 8 right here? That this would now be 8 squared and 8 squared, and that would be 64 and 64, and that would be 64 times 2, and the square root of 64 is 8. Get that? If this is 7 and 7, then this is going to be 49 and 49, and I'm going to have 49 times 2, and I'm going to have 7 root 2. Let's see the pattern here. So, what that tells us is that for all right triangles that look like this, whatever numbers go here are always times root 2 to get your hypotenuse. And it works every single time. If this is 17, this is 17, and this is 17 root 2. Y'all see why it happens because of this. It's a little tough to see. You see how I have a square, and I have a perfect square, and then I have 2 of them? Let me show you with variables. Here's the same triangle. If this side is x, what's this side? And this side, to get c, I take x squared plus x squared gives me c squared. A squared plus b squared equals c squared. These are 2x squareds. And when I take the square root, y'all see I'm taking the square root of x squared, which is x. Now what that allows you to do is put these together very quickly. And I'd like you to grab your little paper I gave you with the triangles on it, and we'll do a few of them. I have to erase mine. This side is 9. This side is 10 root 2. I'd like you to find those missing sides. Fill them in. This side is 9. What's this side? 9. It's just knowledge. It isn't working anything out. It's this side is equal to this side because it's an isosceles right triangle. If this side is 9, this side is 9. What's this side? 9 root 2. You just memorize the pattern. You always multiply by root 2 to get the hypotenuse of an isosceles right triangle. The hypotenuse is 10 root 2, so what are the sides? 10 and 10. You multiply this side by root 2 to get that side. One of the things I want you to keep in mind is that to get from here to here, we divide by root 2. To get from here to here, we multiply by root 2. So if this side is 6, what's this side? 6 root 2. And this side? Just 6. Now it gets a little tiny bit more complicated when you multiply by the square root of 2 like this. If this side, right here, is 3 root 2, see if you can follow the pattern and figure out what to do with it. Give it a try. Throw my desk. My guess is everybody got this one, and then weren't sure about what to do about this. I'm going to color code it and make it easy for you. Whatever is here in purple gets multiplied by root 2 to go here, doesn't it? Whatever's here times root 2. What's this? 2 times 3? And what's this side, by the way? 3 root 2. There is a pattern here that underlies the whole thing, but I want you to get it. It's a little hard to see. That's only half. Now that's half of your special right triangles. There's only one other one. There's only 2. You have to know 2. It's not that hard. You need to know that one. But you also need to know this guy. It looks like this, They always have that shape. This is a 90. You guys have seen this before. This is 60 degrees and this one's 30 degrees. You may not have learned it this way, but this is half of an equilateral triangle. You guys know these things are 60, 60, 60 for equilaterals, right? So if this side is 3, this is half of an equilateral triangle. See it? Anybody tell me what this side is? This side is 6. This side is hard to memorize, or hard to see where it comes from. It happens to be, this is called the long leg, and this is called the short leg, and this is the hypotenuse. And to get to the long leg, you just multiply by root 3. You take the short leg times root 3. Now, just to be a little different, I'm going to show you where that comes from with a specific example, and then I'll show you with a general example, and then we'll go back with the pattern. Here's a specific example. You have a 30, 60, 90. And by the way, you only need 2 of the angles to figure that out. Because if I know those 2, I'm good to go, right? And this side is 5. Find this side, but don't just write this one down. I'm going to actually solve it using Pythagorean Theorem. Can everybody see what this side is by looking at it? That it's 10 because it's half of an equilateral? This side is 10? Okay. This side will always be double this one. We always multiply by 2. So let's take a squared plus b squared equals c squared. What's this? 25 plus b squared is equal to 100. And to get b squared by itself,
Subtract 25.
we get b squared equals
75.
Now we're going to take the square root of both sides. And we get b by itself is equal to the square root of 75, but we need to take out the perfect square factor. Square root of 25 times square root of 3. This is 5 root 3. Now this will always be times the square root of 3, and here's the reason. I'm going to show it to you in general, and then we'll go back to the playing with those. It looks like this. You don't have to write this one. I'm just going to show it to you. It's really easy to see. If this is x, then this side is 2x. Got it? And this is b. A squared plus b squared equals c squared. So x squared plus b squared equals 2x squared. Got it? I have a squared plus b squared equals c squared. Here it is. That is 4x squared. I subtract x squared. And I get b squared equals 3x squared. And when I take my square root, it's always x root 3. Now I'm going to show you the easy way to think of this. Whenever I do these triangles, It's easy to remember. This is the short leg. It's 4. What's the hypotenuse? 8.
8.
And this side is
4.
square root of 3. You always multiply the short leg times root 3 to get the long leg. You always multiply the short leg times 2 to get the hypotenuse. Now if I happen to know the hypotenuse, I can find the short leg, and I can use that to find the long leg. If the hypotenuse is 12, what's the short leg? 6. Because I divide by 2 to get the short leg, because it's half of an equilateral. What's the long leg? 6 root 3 is the long leg, because I multiply by root 3 to get the long leg. If I know the long leg is 7 root 3, I can find the short leg and the hypotenuse. What's the short leg? Somebody say I divide by root 3 to get to here. And this side is double that one. This takes a little bit of practice. The purpose in doing all of this and showing it to you was one problem in particular, but it was that number 7 on your test. They gave you